Hello friends, my name is Deepak Goyal. Welcome to our channel. Today we will solve the problem unique path. So let's first read the statement. There is a robot on an M into N grid. Okay, and the robot is initially located at the top left corner, means at the index of 0, 0, and the robot tries to move to the bottom right corner, that is M minus 1, N minus 1 index. The robot can only move either down or right at any point of time. Given the two integer m and n, return the number of possible unique paths. Okay, means we have given a robot which is stand initially at index 0, 0, and the robot has to go to the finish point which is at n minus 1, m minus 1 index. And this robot either can go into right direction or can go into downward direction. So we have to find out the total number of unique paths. So this is a very easy questions of DP. So first we will solve it by recursion, then we will apply DP and constraint is okay. M into n is less than 100. So let's code it. Basically, we have to return total number of path. So we will return path. Now we have to calculate the total number of path. So first we will define int path equal to 0. Now we will call a function which is a recursive. So find unique path which will take m and 0, 0 and path as an argument. 0, 0 is an I and j which is index. So int find unique path int m int n int I int j and path. Path equal to this. Okay. So what we will do, basically path equal to uh, this function find unique path m n I plus 1 j path plus find unique path, because basically in question it says that our robot can only move in downward direction or in right direction. So we can only go in rightward or in downward. So first we are going in right direction. Now we will call a recursive function for downward direction. So I j plus 1. Now we have to define our base condition. If I equal to 0, sorry, equal to n, or j equal to m, then we will return 0. What does it mean? Means if I equal to n means we are out of this grid, or we can say I greater than n minus 1. And if I equal to n minus 1 and sorry, what happened? J equal to m minus 1, then we will return 1. Why we are returning 1 means we find a path, because if we are at here at n minus 1 and m minus 1 means we are at finish point. So we found a path. So yeah, this is our code. Let's run it. Basically, we have to return this path. Now let's again run it. Compilation error. Let me see. Path equal to find UP declare. Okay. Uh, typing error. Mm, I guess It should run fine. Yeah, it is accepted. Basically, this is recursive in solution. Uh, if we calculate its time complexity, it will be exponential because uh, if we draw its tree, then first we will call it 0, comma 0. Then in next level there are two function call. Then in next level there are four function call. Then in next level there are eight function calls until we will not reach its base condition. So basically, its time complexity is 2 raised to power m plus n, where m plus n is total number of elements. So it will show you. So in order to get optimized solution, we will use DP. So basically, we will define vector in which we will store the answer of our function. So we don't have to need the function again and again. We will just see the answer in this vector and solve our question. So by using DP, our time complexity will drastically reduce. Now our time complexity is exponential, and this by using this vector, our complexity will be reduced to linear. So basically, first we will declare a vector of int of m row and n column. First, we will initialize our vector by -1. So vector int n comma -1. Now we will pass v instead of path. So basically, now we will just return our function. We have to pass this function. Sorry, we have to pass this vector instead of this path. So yeah, so yeah, this condition will remain same. Now, if v of I comma I j if does not equal to -1, that means uh, we calculate our function initially. Now we will see the answer in this vector and we will simply return Vij. So by using this vector, we don't have to need the calling the function again and again. So now uh, we will just return Vij equal to. So now let's run it. This showing me runtime error. Let's see. So yeah, we did mistake. Basically, we are referring I as number of row and j is referring to number of column. So basically in question we have given m into n where m is a number of rows. So I equal to m and j equal to n. This now it will run fine. Basically if I do I equal to n then I have to change vi comma j to v j comma I. So now I equal to m minus 1 and j equal to n minus 1 and here now again run it. What is this queue? Yeah, accepted. Let's submit it. The time complexity is of this code is n into m. Basically, we are traversing each cell only once. So that's why time complexity is n into m. There is no overlapping subproblem. And space complexity will also n into m because we are using this extra space. So yeah, this is optimized solution and you can see the solution here in solution. You can find my solution. I posted it. Uh, you can search Goyal Deepak 13 and you will find my solutions here. Here I write intuition, complexity as well as code in C++. So you can. So thank you for watching this video. Please like, share and subscribe. Bye bye.